Hi, in this lecture we will be looking after the numerical problem solving which are based on the efficiency concept of transform. So we will see question here. It is given that a single phase transformer working at unity power factor has an efficiency of 90% at both one half load and at the full load of 500 watts. Then we have to determine the efficiency at 75% of full load, that is at 3/4 of the load. So first we have to write the values of given or known parameters. At half load we have 90% efficiency. Also at full load we have 90% efficiency. For these conditions we need to get the two equations. We will see how we need to get. So there is also one more known parameters given, which is full load power, that is 500 watts. So this power is active power because units are watts, and it is at unity power factor, right? So then V2 I2 into 1, that is V2 I2 cos theta 2 will be 500 watts. From this you can get I2 full load. So I2 full load will be like, it is I2 full load only. Actually no need to know this I2 full load here. So because we directly need active power, right? Full load active power. So we can directly substitute it in the efficiency formula. Right, okay. Now we will go for the efficiency at half load, which will be equals to 500 into half. Here half is the x in the generalized expression, divided by 500 into half plus pi plus half square into PCU. Here PCU is copper loss, it is full load copper loss, and pi is iron loss, which is constant for any load in a transformer. So this will be equal to zero point 0.9. So this is equation 1. So similarly we have efficiency value of zero point 0.9 at full load. For this also we can get one more equation, which is considered as number 2 equation. So it will be 500 divided by 500 plus pi plus PCU. There won't be any x here because x is equal to 1 because it is full load. Right. So using these two equations we can determine two unknowns of pi as well as PCU. Right. Okay, so once you get PI and PCU by solving this 1 and 2, you can determine the efficiency value at any load. But in the question, it is asked to determine at 75% load. So what you will do, that is 3/4 of the load, then x will be 3 by 4th. So the expression will be 500 into 3 by 4 divided by 500 into 3 by 4 plus PI plus 3 by 4 square into PCU. So you substitute PI and PCU, which we got here, to get the efficiency at 3/4 load. Right, this is all about this first problem. Then if you look after this second problem, so if you read out, it is given that a 100 kVA 1 kV by 10 kV 50 Hz single phase transformer has an iron loss of 1100 watts. The copper loss with 5 amperes in the HV winding is 400 watts. Then we have to calculate the efficiency at 25%, 0.8 power factor, and it is given that the output terminal voltage being maintained at 10 kV. Fine, it is maintained at 10 kV, which is nothing but V2. Right, so first you need to write the given parameters, and PI is also given, which is iron loss 1100 watts. Then I2 is given 5 amperes, at which the copper loss is 400 watts. Okay, so now from the rating of the transformer we will get I2 value, that is full load, because rating is always done at full load condition. So here this I2 will be full load when we consider kVA as rated kVA, because it is given as 100 kVA. Rated kVA is equal to V2 into I2. So V2 is given as 10 kV and into I2. This I2 is nothing but I2FL because it is rated kVA, which we are getting as 10 amperes. Fine, right. Now we are also given with the copper loss when I2 is 5 amperes, which is 400 watts. So what is that condition that will give you copper loss value? Because this 5 ampere is now half load, right? Because full load current we got it as 10 amperes. Then 5 amperes will be half load. At half load they gave you 400 watts copper loss. That means 1 by 2 whole square into PCU is equal to 400, where PCU is the full load copper loss. Then you will get full load copper loss as 1600 watts. Now with this PCU value you can determine the efficiency at any load, because we are already having the value of Pi, which is iron loss, right? So now at 1/4 load we are asked to determine efficiency. Then what it will be? kVA, that is V2I2 into 1 by 4 x into power factor, right? Divided by the same thing, power output plus Pi and PCU into 1 by 4 whole square, which will be 1 by 60. So with this expression you can get the value of efficiency at 1/4 load, right? Like this you can proceed to solve this problem. Fine. Now we will see one more question, the another type of efficiency problem. So here it is given that a 50 kVA 1 kV by 10 kV 50 Hz single phase transformer has an iron loss of 1200 watts, and the copper loss with 5 amperes in the HV winding is given as 500 watts. Then they asked us to determine efficiency at different loadings, 25%, 50% and 100% of normal load at a power factor of 0.8. Okay, so similar to the other problems, first we will write the given values. Then what about Pi? Pi is also given as 1200 watts, and we are also given with the copper loss when current is 5 amperes, which is 500 watts. So that will be what we need to get actually I2 here. We don't need to get R2. This part is not required here. Okay. So how to get actually we need to determine the loading, or this 5 ampere is whether it is full load or half load, that we need to determine. Okay. For that what we need to know? We need to know the full load current first. Right, how to get the full load current? As I told, the full load current will be determined at the rating of kVA. So we have given with the 50 kVA rating, so which is nothing but V2 and I2, and in ideal case it will be E2 I2. So E2 I2 will be 50 kVA, where I2 is full load current. Okay, because it is rating. So what is E2? E2 is given as 10 kV, so it is 10 into 10 cube. Then with this equation you will get full load current, which is rated current. Fine. So what is the value of that? It is 5 amperes. That means whatever is the copper loss that is given to us, it is at full load condition only, because it is given at 5 amperes, right? Okay. With that you can say that PCU is 500 watts. PCU. Okay. This is PCU. Okay, right. Now we can determine efficiency at any loading value, because we got PCU as well as iron loss, and we also have power factor which is given, and we also have full load rating or output power. So at 100% efficiency it will be 50 into 0.8 divided by 50 plus 500, which is full load copper loss, plus 1200, which is iron loss. So if you solve this, you will get the value of efficiency at 100%. Similarly, we can get values of efficiency at 25% as well as 50%. What you have to do, you just need to substitute x value. For 25% x is 1 by 4. For 50% x is 1 by 2. Right? Like this, you can get the efficiency values at any loading condition. Right? Thank you. This is all about the problems based on efficiency concept of transformer.